Hello people at Desmos. This is Mike May at St. Louis University. I've tried out various recording constructions that they have here, and the ones that show me in front of a board simply don't work well for mathematics. So I'm going to use Word for what I do as a board and Desmos for what I would do on the screen at Desmos. The basic thing I use Desmos for right now is I try to encourage my students, whenever you do anything algebraically, you should pretty much immediately look at a graph and see if what you've done on the algebra side makes sense on the graphing side. So what we've been doing in College Algebra for Business recently is parabolas. So we're going to look at parabolas. Excuse my typing when it happens. An awful typist. And so if we start with f of x equals ax squared plus bx plus c, that's the standard form. The vertex form is g of x equals a times x minus h squared plus k, and the factored form is I'm going to say m of x equals a times x minus r1 times x minus r2. And we've seen in class that we want to be able to convert back and forth from one of these forms to another. So I'm going to look at a specific example. So I'm going to start with y equals 2x squared plus 2x minus 12. And I'd like to convert that to vertex form, so I need to complete the square, equals 2 times x squared plus x minus 12, x squared plus x, not plus 2, equals 2 times x squared plus x plus, I take 1 divided by 2, get a half, square it, get a fourth, so plus a fourth to make a perfect square, minus 12 minus 2 times 1/4. And in final factored form, that's 2 times x plus 1/2 squared minus 12 minus a half minus 25 halves. 25 over 2. I'm also going to look at what happens if I try and do it in factored form. And in factored form, this is my original equation. I'm going to factor a 2 out of front. X squared plus x minus 6, and that equals 2 times, I think of how 6 can factor. 6 factors as 3 times 2 when they have a difference of 1. So I'm going to say x plus 2 times x plus 3. Now I have my 3 forms that are all supposed to be the same equation. And so what I'd like to do is go to Desmos and graph them and see if I get the same thing. And so the first one was f of x equals 2x squared plus 2x minus 12. And my second one is g of x equals 2 times x minus 1/2 quantity squared minus 25 over 2. And I'm looking and seeing that's not the same thing, so I have to compare notes. And it wasn't minus 1/2, it was plus 1/2. So if I don't get the same thing, I want to check back to see if I made a typing error. And h of x equals 2 times x plus 2 times x plus 3. And once again, that's not the same thing, and so I go back and check my work and see that if I have x plus 2 times x plus 3, that isn't a correct factoring of x squared plus x minus 6. I need to make this x minus 2 to factor it correctly. And that also matches up that 2 and minus 3 are the roots of the original one. So I'm going to come in with minus 2. And when I do that, all three of my parabolas, all three of my versions, are the same parabola. If I zoom out, I have what I've referred to in class as the 4 special points of a parabola: 2 roots, the vertex, and the y-intercept. The y-intercept is given by the standard form. The 2 roots are the negative of the numbers given in the factored form. And the vertex are the numbers, the negatives of the numbers given in the, or the negative h and k given in the vertex form. Now, one of the things that's nice with Desmos is we do this first of all and simply say whenever you do algebra, you check your work by looking at the visualization, and we spotted a place that, one, I copied wrong, and one, I made a mistake in factoring, but as soon as I check my work, I find it, and I find I'm likely to spot it when I check my work independently, as opposed to check my work by just looking and saying, does it look right? Very few people are good at proofreading their own work. A further use of Desmos that we want to look at is, I've done this in general, but I'd like to be able to do it for a more generic case. So I'm going to create sliders and have a parabola there. And this should be a minus h plus k. And it's saying h is a function of some sort, because I have used h as a function down here. So I'm simply going to make this, well, let's change this to m to match what we did before. And now I have my functions, I have my parameters, and m should be minus r1 and minus r2. This gives me 3 ones, so that if I pick an interesting parabola like a is minus 3 x squared plus 6x, I want it to actually intersect, and so I'm going to say plus 4. That gives me one that if I look at it, I'm going to say that vertex is at 1, 7, so I'd like to have 1 and 7, and we get those two the same. This should also be an A. So they're in the same direction. And now my roots are at ugly numbers, x 2.53 and minus 0.53, R1 and R2. So 2.5 and minus 0.5. And that gives us about the same equation. If I wanted to get it more precisely, I'm going to go from minus 10 to 10 and make my step 0.001 so I can get more accuracy on it. Nope, still only getting 2.53 and minus 0.5. But again, it lets me generically look at it and say, I have these three forms. I'm going to do algebra to find out the important stuff. Once I found the algebra, I'm going to want to make sure by looking at the graphs that I've got three different versions that are the same curve each time. Now, the next thing I'd like to do, and this is a follow-up with the same thing, but it's beyond my Desmos experience at this point, is I'd like to turn this into a short about 3-panel Desmos activity, because I like to start class with what I call a warm-up problem that says, let's take a simple problem that we did last time in class, or like we learned last time in class, and have people start on it in groups, and would like to be able to do the superimposed what the class is getting if you're given general form and asked for vertex, and doing that and having the students work it out and see the results all together. Thank you very much. I hope this all works.